Yes, can you see me now? Yes, Joshua, can you see me now? Okay. So can you see me now? Okay. So understood now how to represent, it's easy, not tough. Okay. If we want root 2 unit, what how much our length of the base should be? How much? One lesser than that, no? One. For root 2, perpendicular should always be 1, 1, 1, 1 we will take, okay? So for root 2, base should be 1. For root 3, what should be the base? For root 3, root 2 man, root 2, not 2. 2 and root 2 are different. Root 2, no? For root 5, what should be the base? Root 4, why you're late? Root 4, and what is root 4? Root 4 is how much? Square root of 4, 2. So the base should be 2 in this case. Okay. Now for root 7, how much should be the base? For root 6, the base should be so easy. No. Now let us see. Let us see some of them. 3.4 root of this. Is it irrational or not? Square root of 3.4. Yes. Is it irrational? Yes. It's irrational. Okay. So how to represent the decimal fraction values? The irrational of the decimal fraction values. How to represent that? So there is a direct way. See, if I'll ask you, represent root 6, can you represent directly without representing root 5? If I'll ask you, represent root 6 on the number line, can you represent? No. You have to first show root 5. Without root 5, no. So you have to first show there root 5. To show root 5, you need to show root 4. To show root 5, you need to show root 4. And root 4 on the number line is clear. Root 4 on the number line is clear. How much? 0, 1, 2, 3. Where is root 4? Where is root 4? So why late? I don't understand. Why? They're thinking a lot. Root 4, hey, root 4 to think something. 2, root 9, root 9, what to think so much, man? 3, root 16, okay. So root 2, root 4 is here, 2. And then take 1 unit perpendicular. Next, what to do? 1 unit. So how much this? Root 5. Represent this root 5 here. And then draw perpendicular again. And then join this. This is root 6. Represent root 6. So we got root 6 value. And this way, this is 0 to 0, root 6, 0 to root 6 unit. Like this we can represent, okay? For representing root 5, no need to represent root 3, root 2. Clear? Okay, if question will be there, represent root 3, then how will you represent? Represent root 3, then represent root 3, root 2, no, base as the 2, and to represent root 2, we need what? Say, to represent root 2, what we should do? Take. To represent root 2, what we should do? To represent root 2, what we should do? We want to represent root 3, no? So for root 3, the base should be root 2, means we want on the number line root 2 point. So to represent root 2, we need something to do or not? What we need to do? This we want to represent, this. Hmm. So where is root 2? How we will understand where is root 2? So where is root 2? Where is root 2 on this number line? So how to find that? That I am asking, no? How to find root 2? It's not so tough that you are trying to understand in so tough way. I don't understand why. I just want to say that root 3, for root 3 we actually need to represent first root 2. Without representing root 2 we cannot show root 3. That only I want to say on the number line like this. And how to get root 2? Simple, this will be 1 unit, this will be 1 unit, 1 and 1, and then this will be root 2. Okay? Now the question is that how to get this decimal fractions root. Okay, so there is a direct, yes. Any value is there, we can get easily. See how. What is this? 3.4, no? Hmm. So this will take 3.4. Any length 3.4. How much it is? 3.4 units. Can we represent 3.4 units on our notebook? Suppose 3.4 centimeter we represented. Okay? No. No. Suppose take the centimeter as unit. 1 unit means 1 centimeter. Then how much 3.4 unit? 3.4 centimeter. No. If we consider 1 unit as 1 centimeter, if you want to represent on our notebook, then 3.4 unit means how much? 3.4 centimeter. So this 3.4 unit I have represented, suppose, okay, on the page, on my notebook. Okay, next what I will do, next step, this we need to find. So next step will be from here, extend it to 1 unit, extend it to one more unit, a straight line. It should be a straight line, okay. How much this length? 1 unit. Okay, this length as 1 unit. This is 3.4 unit, this is 1 unit. Fine. So we got total this length 4.4 unit. No, 3.4 plus 1. If this is 3.4 centimeter, then this will be 1 centimeter. If this is 3.4 meter, then this will be 1 meter. So total we got this much length or not? Now what to do? Find the middle point of this total length. Find the middle point of this total length. So how to get the middle point? How to get the middle point of this total length? No, you can measure also, but see, there is a way of use your compass. Okay, use your compass. Keep your needle here. This is needle. Okay, this point is needle. Keep your needle here. Take approx more than half. This is almost half. This is more than half. Okay. So keeping your needle here, taking a length more than half. What you do? You draw a. What you do? You draw arcs both the sides like this. Okay. With your compass. And how much length you have taken? More than half. Now take the same radius, keep the same radius, don't alter this, don't change this. Keep the needle at the other end of the line and then cut the arc, previous arcs. What I told? Any line is there, any line, okay, any line. If we want to get the, if any line is there, if you want to take the perpendicular bisector, then what to do? Keep the needle here, take more than half length and draw the arc. Draw arc, both the sides, up and down. And with the same radius, don't change this compass size. Keep the same. Keep the needle here at the other end and then cut the previous arc. What will happen? These 2 points you will get. Joining these 2 points, we will get the perpendicular bisector of this line. We will get the perpendicular bisector of this line. This line you will get a perpendicular bisector. Perpendicular bisector means perpendicular also, making 90 degree also this line, and bisector also means equal, dividing it into 2 equal halves. Means this is the middle point of this line. For any line you can do, any random line, no problem. Okay. No need to measure how much point centimeter, this much, and then divide it by 2, and then again measure and come. Errors will come in that. So what to do? Any random line, no problem. Take more than half, draw the arcs both the sides, keep the needle here, cut the previous arcs, join them, you will get the middle point here, and also this line will be perpendicular, making 90 degree with the given line. Okay, this is the standard method. Clear? So again, listen properly. Concentrate. Yes. 3.4, 3.4 I drew. After that, 1 unit extra I drew. Okay, always 1 unit. And then of the total, what I did, I took the perpendicular bisector. I found the perpendicular bisector. When I found the perpendicular bisector, then I joined it. I got the point. I got the middle point here. Clear? After that, what to do? What to do after that? Keep the needle here, middle point. Keep the needle of your compass here. Measure this much length, and then draw a semicircle. Draw the semicircle here. Okay? Yes, Yoshua, any doubt? Okay, what we did, explain, come on. First we took the value of which square root we need to find. We took the value, this much. Then what? After that, what we did? Hey, after taking this value, after taking this value, 1 unit extra we took, no? Okay, next what? Then find the middle point by drawing perpendicular bisector. After that, draw the semicircle. Okay? After drawing the semicircle, what to do? After drawing the semicircle, what to do? Come at this point. Where? 3.4. Where your 3.4 was ending. Come to this point, okay? And then from here, draw a perpendicular line. From here, draw a perpendicular line. Okay? So wherever this perpendicular line will intersect the circle, wherever it will intersect, this length will be square root of 3.4 unit. This length will be square root of 3.4 unit. This length. Okay? This length is square root of 3.4. Okay? Square root of 3.4. This is the length. So where the 3.4 unit was ending, from there, that point we drew what? One perpendicular line making 90 degree. Okay? Wherever this was intersecting the semicircle, from that point to this point, we have the length of root 3.4. Fine? Now the question is how to draw the perpendicular line. How to draw? You have the set square. Do you have the set square in your compass box? Like this, two triangles are there, no? No. You have or not? Two triangles are there. So what to do? What to do? When this is not there, what to do then? Bring this compass here like this and match this edge with this line. Okay? Match the edge with this line. The edge of the compass. This edge of the compass. Match it with this line. Okay? And this point with this point. Okay? So it will come something like this. Okay, and then you use your pencil and draw it straight line like this. You will get a perpendicular line on this point, and then remove your set square. Okay, and then measure this length and this length. This is root 3.4. Okay. Now what to do? We actually are representing this value on the number line. We are representing this value on the number line. So we got this value. This much is the length. We got it from our construction. We got this much is the length of root 3.4. We need to represent this on the number line or not? Yes, we need to represent. Okay. So what we will do? This will be our construction work. That should be shown on the fair page. Okay. Then the next on the number line, what we will do? We will mark. Now we will take the same units. If we have taken here 1 centimeter, 2 centimeter as 1 unit, 1 centimeter as 1 unit, 3.4 centimeter as 3.4, then equally we have to take here. This is 1, this is 2, this is 3. Okay. So next what we have to do? We have to take our compass and we have to measure this length. We have to take our compass and we have to measure this length. Okay, and then come to where? On the number line, keep your needle at 0 and then what to do? And then mark this, yes, arc, that the same arc. Okay, cut here, fine, somewhere here it will come. Okay, so this will be 3.4, root of 3.4 units. This way we can represent our decimal fraction, root, square root, or the irrational numbers of the decimal fraction on the number line. Okay. Got this? Okay. So for root of 7.5, what we can do? Can you explain me? Okay, take 7.5 centimeter. I am taking. Okay, 7.5 centimeter. Wait. 7.5 centimeter I took. Next what? Next. One centimeter, no. 1 centimeter, no. So took 1 centimeter. The same straight line, 1 centimeter, yes. Next one. Take the complete length. Measure more than half with the help of compass. Measure more than half and then draw the arc. And then join these points. Next, keep the needle of the compass here at the center. This much done, no? Next what? Here, this point. This point, what to do? Hmm. So this will be root of, and this only we need to represent on the number line further, no? So this is 0 and 1, 2, 3, 4 like this. So measure this and then represent wherever it will cut, that value will be root 7.5. Okay? And then we can write root of 7.5 units. Okay? Understood this? Okay. So today we studied the representation of irrational numbers. Fine? Fine? Okay. And now tell me the numbers. Revision of the previous class. Tell me what two groups? What two groups we have seen? The numbers. The numbers, total numbers can be broadly divided into two groups. Which two groups? Hmm. Okay, then the real numbers. Yes. Okay. Now define what is rational number. Come on, define it fast. Define. Listen. What is rational number? should be integers, okay, and the denominator should not be equal to 0, okay. What is pi, rational or irrational? What is pi, rational or irrational? Okay, pi is irrational, good. And what is 22 by 7? Yes, why it is a rational number? Why 22 by 7 is a rational number? Okay, of being rational number, good. Then what are irrational numbers? What are irrational numbers? Hey, real numbers which are not rational. Rational and irrational, both are real numbers, no? So among the real numbers, those which are not rational are irrational. Hmm. We have seen root 2, irrational, okay? Fine? Now, tell me this. The decimal fraction, types of decimal fraction. Types of decimal fraction, tell me. What are the two main types? Yeah. Yes, I can hear you, Sinu. Say, man. So that I didn't listen. What you are doing? Where did you say? Non-terminating is no non. See, decimal fraction terminating and non-terminating. Okay, listen. Then non-terminating, non-terminating, recurring, non-terminating, non-recurring. Okay. What is terminating decimal fraction? What is? Yes. Yes. Hmm. Yes. Yes. So in the non-terminating, we are getting two types of division. While dividing some fractional values in the non-terminating, which is not stopping, we are getting two types of division. The one in which we are getting the quotient as repeated one again and again, either single digit or a group of digits are getting repeated. Yes, digits, one digit or group of digits. So it yes. So this terminating is coming in rational or irrational? What? Rational number or irrational number? Which one? This terminating? All the terminating decimal fractions are rational or irrational? What? You are taking time, man. Rational. Then come to non-terminating, recurring. Tell me. All the non-terminating recurring ones, those which are getting repeated, are rational or irrational? This one. Rational or irrational? Okay, good. Now, all these numbers are real numbers or not? All these numbers are real numbers or not? Yes, all these are real numbers. Okay, fine. So, this much for today's class. Okay, tomorrow, same time. Monday, Tuesday, what? We should start science or we should finish this real numbers, number system. Let us finish this number system in two classes. In more two classes, Wednesday and Thursday, we will finish this, okay? Fine? Okay. Yes. Okay then. Have fun. Bye. Bye. Take care. Bye. Okay, man. I will take care. Thank you.